Hello, this is an introductory video to CASAXPS software, and in this video I'll show you how to load a XPS data file into the CASAXPS, and I will introduce some of the buttons shown in the top taskbar of the CASAXPS. Okay, so first we can go to open a data file. That is, you have to go to file and then click on open. Okay, so this is the one of the data file I already saved, and this is also available with the CASAXPS software. This is a template data, and here you can see this data file should be in VMS format. That is, when you are doing this XPS measurement in particular system, you have to save the data in ISO 14976 format. Okay, that is ISO format. If you have saved this data in ISO format, you can easily recall this data in CASAXPS. So that the data file format will be .vms, that is VMS. Okay, so I am opening this data file. So if it is in a .vms file, then you can easily open in CASAXPS software. So just click open. So the data is loaded here. So this is not the usual case for most of the users. So for most of the users, they will get data in Excel sheet. Okay, in that case, you have to convert this data into a VMS format. Okay, so how we can do that? That's what I'm going to tell you. So you have to copy this data first. That is, this one is binding energy, x-axis is binding energy, and the next column is counts per second. So I'm copying this data. Okay, and I am making a notepad file here. That is a wide scan. Okay, I'm naming as wide. I'm opening this notepad file and pasting this data. Okay, that is binding energy and count per second. So this is an XY file. Okay, so in this XY file, you have to remove this top comment and any spaces also. Okay, so you can see the X is binding energy and Y is counts per second. Okay, so now you have to save this data, file, save. Okay, so this data is saved here, and this is saved as a text document. Okay, now you have to go to CASAXPS and file. Instead of open, you have to convert that text file into .vms file. So you have to choose this convert option and select that particular data. That is, I saved in desktop. Okay, so this is that data. So this data is in text format. Okay, so we are going to convert this data. So I am opening this one. So see, that is loaded here. So now you can check that folder. In that folder, you can see there is a file is created, that is VMS file. Okay, so we converted this text document into VMS file. So here I can minimize this window. That is, these are called as different experimental frames. So this one is silicon template experimental frame, and this one is white. This data is saved in ISO format. So all the information like instrumental information like pass energy, energy step size, and what is the instrument name, and all these informations are available with the ISO data file, that is VMS file. Okay, but here you can see we already converted one Excel file. So in that also we can see this acquisition parameter, but you can see there is some information are missing. That is, what is the pass energy used here, and what is the acquisition time, okay, and what is the instrument used. Okay, so it is better to collect data in ISO format if you are going to do the analysis in CASAXPS. Okay, if you are getting the data just in a Excel format, then you will be missed of the instrument information, that is pass energy and like that. Okay, so if you are using the CASAXPS software, then it is better to collect the data in ISO format. So all the information will be with this data set, and one more information will be available with the ISO format, that is transmission function. Okay, so this information is missing with our converted data. Okay, but the transmission function data is available with ISO saved format. We will discuss more about this transmission function and all when we are doing this quantification. So now don't be bothered about transformation function and all. But what I am telling is, if you are collecting the data in Excel format, then all this information will be missed. Okay, that is, we just now loaded the data. So it's another XML frame, and you can choose this different XML frames. If it is a full screen, then you can choose this different XML frame from window. Okay, so this is silicon template, and this is byte. And here you can I'll show you some of the options here. That is, by clicking on this window, display window, you can see some of the options here. So these are the options for viewing this data. Now I will show you how we can see the acquisition parameter from this one. So I'm choosing this silicon template data, and I'm choosing this display parameters. So you can press F6 to open this dialog window. So in this dialog window, display parameters, I'm going to tick this acquisition parameters, and I'm going to apply this. So now you can see the acquisition details of this data. So this pass energy is used this 160 EV, and energy step size is 1 EV for the wide scan, that is for survey scan. Okay, so I'm going to click OK. Okay, and the source use this aluminum, and it's monochromatic source, and the instrument use this Kratos axis ultra. Okay, so this information we can see from this option, that is display parameter, and go and tick on this acquisition parameters and click apply. Okay, so here this is a wide scan, and this one is narrow scan of oxygen 1 peak. So for narrow scan, they used 20 EV pass energy, and step size is 0.1 EV. Okay, and here acquisition time is mentioned, and the source is mentioned, and instrument is also mentioned. So you can see for wide scan they used 160 EV pass energy, and when doing narrow scan the pass energy is reduced. So it should be some 20 to 50 EV for narrow scan, then only you will get a good resolved spectra in narrow scan. So here also this is a narrow scan of silicon or high resolution scan of silicon. So in that case they used step is only 0.1 EV and pass energy is 20. But when you are taking this survey scan, you can increase the pass energy to 160 EV, and you can reduce the resolution also. That is, here it is used only 1 EV step size. This is the option to view the acquisition parameter of your data. Okay. Next thing we can see the x-axis is binding energy and y-axis is cycles per second. We can change this x-axis and y-axis names. So you have to go here. If you want to change this binding energy to kinetic energy, click here. Okay, so x-axis is changed to kinetic energy to binding energy to kinetic energy. Okay, so again clicking, you will again shift to binding energy. So you can change between kinetic energy and binding energy by clicking button here. And y-axis you can see it is in cycles per second, and you can change it into arbitrary unit by clicking this button, that is CPC to counts. Okay, or you can change into intensity. Okay, so again you can press, so it become cycles per second. Okay, so again if you click on that button, it become arbitrary unit, then it become intensity, then it become cycles per seconds. Okay, and if you want to see this spectral line in a zoomed view, you have to draw a rectangle here, clicking the left button of mouse here and drag, and click inside this box, so it will be zoomed. Okay, to zoom out you can use this button, that is reset button, and you can, to zoom, you just draw a rectangle over that particular peak, then click inside that peak. Okay, so you'll get a zoomed view of the spectrum. And to reset, you can click here, that is reset button. And another thing is you can move this window, like we already chosen some of this peak, and if you want to move the peak to right side, then click this button. Okay, that is step right, and you can use this button step left button to move it left side. Okay, and this is to reset. And suppose I zoomed this one like this, so the upper part of the peak is cropped, so you can change this scale. So we can increase this Y scale, or we can decrease the Y scale by using these two buttons. So here I want to increase the Y scale. That is, this is the Y scale. So once I am increasing the Y scale, you can see the entire pic is inside this display window. And if you want to maximize to see this particular pic, then you can use this decrease Y scale. Okay, so it is scale is decreased and here scale is increased. And to reset, you can press this button, reset button. Here you can see there are three datasets. One is wide scan and another is Oxygen 1S high resolution scan and Silicon 2P high resolution scan. Okay, so if you want to see all this data together, you have to click here in the dataset name. So you can scroll down and you can see this data. And if you want to see all this data together in single display, then there is an option. You have to go to page layout and I have to arrange all this data in columns. So there are three datas. So I am choosing 3 column and in 3 column this data will be arranged. See, all the 3 data is arranged in by 3 column. So we can see all this data together in single display. Or you can choose another thing, that is row. So I'm going to arrange these 3 datasets in 3 rows. So see, you can see all this dataset together in a single window by using the option that is page layout.